Hello and welcome to this SDXL quick take video, N-Dimensional Kernel Range. An N-Dimensional Kernel Range is specified using two variables: global, which defines the total number of work items the kernel will compute, and local, which defines work group size. A work item is the basic unit of work that executes on the custom data path of the FPGA. Global declares the n-dimensional size of the total number of work items to be processed by the kernel. Typically, the size and dimension of the global variable corresponds to the size and dimension of the computational problem, for example, an array to be processed. This total number of work items is broken up into work groups. A work group is a set of work items that executes in parallel, and the n-dimensional work group size is set using the local variable. One-dimensional kernel range. The global and local variables can be 1, 2, or 3-dimensional. Typically, the number of kernel range dimensions corresponds to the number of dimensions in the dataset or array to be computed by the kernel. A host code example of a one-dimensional kernel processing an 8-element array is shown next. First, the host declares global and local variables as arrays of size 1, corresponding to the number of dimensions in the kernel range. The array to be processed contains 8 elements, and as a result, global is set to 8, indicating a total of 8 work items to be processed by the kernel. The size of local can be between 1 and 8, and it must be a factor of global. In this case, valid local values are 1, 2, 4, and 8. In this example, we use a local value of 1. Next, the host code launches the kernel using the CL-NQ ND Kernel Range API, and it includes pointers to global and local as arguments. In the first example, the FPGA is programmed with one compute unit. Because the work group is size 1, the compute unit fetches and processes one element at a time, starting at element 0 from the array. When the work group completes, the next element is fetched and processed by the compute unit until the entire array is traversed, resulting in a total of 8 consecutive work groups. When the work group size is increased to 2, the compute unit fetches and processes 2 array elements at a time, resulting in a total of 4 sequential workgroups. Parallelism can be increased by programming the FPGA with 2 compute units, allowing for processing of 2 workgroups at a time. Compute Unit 1 fetches and computes the odd elements, and Compute Unit 2 fetches and computes the even elements in the array, until the entire array is traversed. Similarly, with a workgroup size of 2, each compute unit processes 2 array elements, resulting in a total of 4 workgroups, processed in parallel 2 at a time. Two-dimensional kernel range. An example of a two-dimensional kernel range processing an 8x8 array is shown next. First, the host code declares global and local as 2-element arrays, corresponding to the 2 dimensions of the kernel range. Next, both elements of the global array are assigned 8, resulting in a total of 64 work items to be executed. Similar to one-dimensional kernel range, the size of local can range between 1 and the size of global, which in this example is 8. In addition, each dimension of global has to be a multiple of the corresponding dimension of local. In this example, the workgroup size is set to 1 by 1. Finally, the host launches the kernel and passes the pointers to global and local. A single compute unit with a work size of 1 traverses the 8x8 element array, fetching 1 element at a time, resulting in 64 consecutive workgroups. When the workgroup size is increased to 2 by 2, the compute unit fetches and computes 4 elements at a time, resulting in a total of 16 workgroups. Similar to the one-dimensional case, Parallelization can be increased by programming the FPGA with 2 compute units. When work group size is increased to 2 by 2, consecutive chunks of 4 elements are processed in parallel by the compute units until the entire array is traversed. 3-dimensional kernel range. An example of a 3-dimensional kernel range processing an 8 by 8 by 8 array is shown next. First, the host code declares global and local as arrays with 3 elements each, corresponding to the 3 dimensions of the kernel range. All 3 elements of global are assigned to 8, resulting in a total of 512 work items. Local is set to a workgroup size of 2 by 2 by 2. The host launches the kernel and passes the pointers to global and local. A single compute unit fetches and processes 8 elements at a time from the 3-dimensional array until the entire array is traversed. 2 compute units fetch 8 elements each and process them in parallel. Similar to earlier examples, the compute units fetch interleaved chunks of data until the entire array is traversed. In summary, this quick take video described an N-dimensional kernel range and defined a work item as well as local and global variables. For additional information, go to xilinx.com/sdxl or contact your local Xilinx representative. Thank you for watching.